One thing that's noticeable about the Orange Pi is that the CPU chip, the SoC, gets really hot, and in fact it's so hot you can't really keep your finger pressed down on it for any length of time, and it can be up in the 40 degrees or even 60 degrees I've seen. So if you look at the log on screen here, you can see on the left, center left there, it says 42 degrees at the moment, and if we run the ambient monitor, which we can get this to show us the temperature, so it shows us a continual reading of temperature. So you see on the right hand side there we've got a reading of 40 degrees centigrade, which is really rather hot. I've got an error message coming up there, so I'll just log in again using root. So I'll sudo and run that command again. So there we go, it's reading 41 degrees now, and it's quite a warm day, but 41 degrees seems very warm. You see on the left there's a column marked CPU, so you can actually see the clock speed of the clock of the processor. So when the Orange Pi isn't doing much, it switches the clock speed down. So what you tend to see is when the clock speed is high, you get the maximum temperatures, and when the clock speed goes down to 240, you tend to see a drop in the corresponding temperature. So I've got two windows here, and what I'm going to do is run a CPU benchmark in the left hand window to give the CPU something to do, keep it busy, keep the clock speed high. And in the window on the right hand side there, you can see that's the ambient monitor, so you can see the temperature. So you see as the clock speed has gone up now, the temperature's gone up into the 60s, so that's now reading about 64 degrees with the CPU benchmark running. And you see correspondingly when the CPU benchmark has ended and the clock speed goes back down, you see the temperature of the SoC drop back down again. So we're now back at around 44 degrees, isn't it? So as a first step, I'll put this heatsink, just balance this heatsink on top. So this is an aluminium heatsink. It was for a bigger processor, but I've just hacksawed it in half, so I've got something to put on the top of the SoC there. It's got some quite nice long aluminium veins, so it should give a good cooling effect. So first of all, if we have the heatsink just balanced on the top of the Orange Pi, you can see when I'm running the benchmark, the temperature's up around 58, 57. So we've already made a small improvement to the temperature, operating temperature. Oh, we had had a reading in the 60s there, but it's gone down to the high 50s. So it's well worth having that heatsink in place, I think. So for the next part of the experiment, I'm going to put some heatsink compound on the top of the SoC, which helps the heat conduct from the top of the chip into the heatsink. Just need to squeeze a blob of this stuff on top. That's a bit too much. Let's try and wipe some off. Now put the heatsink back in place. So we'll run the test once again, start the CPU benchmark. Now we're looking at the temperature in the right hand window, see how that's doing. Well, that seems to be quite a big improvement. So we got what's in the high 40s, so the temperature's in the high 40s with the maximum clock speed. So that's a big improvement over the bare chip with its 60+ degree operating temperature, and that should mean that the CPU lasts longer if it runs cooler. So finally, I managed to find in one of the component boxes, I found one of these little aluminium heat sinks. I bought these for a Raspberry Pi, but of course they're exactly the same size as the sock on the Orange Pi. So I've just taken one of those and stuck it to the top to get a bit more cooling on the Orange Pi. So this is not quite as good as the tall one that I had on there for experimenting, but it is self-adhesive, so it was easier to put on there. This is still really hot, by the way. You can't really keep your finger in contact with that because it's so very hot.